Great. Well, welcome everybody. My name is Stephen Williams. I'm the service lead for learning analytics and for the Berkeley Online Advising platform in research, teaching, and learning at UC Berkeley. And I'm joined today by my colleague, Sandeep. Do you want to introduce yourself too?
Hello all, I'm Sandeep Jayaprakash. I work as a lead data scientist and a platform architect within the same group, research, teaching, and learning. Glad to be here and looking forward for a very good conversation.
Great. So today, Sandeep and I are going to be speaking a bit about our work with the BOA Berkeley Online Advising platform, and then how it fits into some of our larger strategic conversations and goals around both technology innovation as well as what we'd like to do in the learning analytics domain. Just to start things out, I'll say that BOA is just the BOA team is also the team for many other products and tools, and you see some of them here. You'll probably hear me say B courses or see that word on screen at some point today. That's just our local branding for the Canvas LMS. Our team is also responsible for any number of customizations and deployments of vendor tools, as well as custom development of platforms like BOA. And we're comprised of developers, data science expertise, user interface, and experience design expertise. So a pretty robust team of folks supporting the work that Sandeep and I are sharing today. And as I mentioned today, I'll start out by doing a quick overview of some of the work we're doing on BOA today and the platform itself. Sandeep will speak a bit about the data architecture that underlies BOA and how we've powered it. We'll both speak about some of the strategic impacts technically and functionally, and then I'll talk a little bit about how this aligns with some of our future and current goals around learning analytics. So I wanted to also give some context that BOA is a platform that's been in production for about 2 years now, but is a project that's evolved over many years. And so this goes back really 5 or more years and starts with some strategic decisions that were made on a policy and platform level around a more consolidated approach to student information systems, Berkeley's early adoption of the Canvas learning management system, and Berkeley being a pretty early adopter of some of the work that was happening and being championed by IMS around learning record stores. We've sort of evolved that into the data lake today, but really this idea that the data being generated by Canvas and other learning tools had values and would allow us to find insight about students. And without going into every bullet point here, I also just want to outline here that BOA is really a story of partnership. Our work with BOA has required us to develop new partnerships, maintain existing partnerships, and really align what the BOA platform is for advisors with what the strategic needs are around advising at UC Berkeley. And BOA's been in production for a while and it gets a lot of traffic. We only have about 1,000 staff at our institution with access to BOA. It's really focused on undergraduate advising, but they're very active in the platform. One of BOA's features that we won't talk so much about today is the ability to author advising notes. And we've had over 160,000 of those advising notes written in BOA just in the past 2 years. So this number of staff is spending a lot of time in BOA. They're really engaged with the platform, with the records, and with the way we represent data. Part of the reason for that is also, in addition to the transactional innovations, we've also used BOA as a way to provide access to previously siloed data. And so bringing these external systems into the data lake to sort of champion this principle of advising resources being something that serve students and serve advisors best when they're shared. So I'm going to do a really quick demo of BOA, and this is just going to scratch the surface, but I just wanted to provide a little context. I stopped my screen share instead of what I meant to do, so let's get that back up. 1 second. Here we go. So this is a live demo. So this is our demo environment. This is my homepage in BOA, where I've built a lot of what we call cohorts and groups, which give us ways to kind of track students of interest. And with our cloud-based architecture and with our data lake model, we've been able to build something really performant with BOA, given the scale at which a school like Berkeley operates. I can do a kind of real-time query of student records based on a combination of criteria that come from multiple sources. And for the end user, it doesn't really matter. They don't need to know all the different ways that we source this data. They just really want to see the outcome of being able to sort of track and identify students of interest. So here I'm just going to do a really simple query, students who are declared geography majors who are expected to graduate this spring. I can run this, again, this is a live demo, so I'm able to really quickly query against 30,000 records, create this cohort of 18 students, and really at a glance understand a bit about these students, who they are, what their GPA trends are, what their current enrollments are. The exact sort of format and contents of this page have evolved over time in response to the needs from advisors. BOA is something we built ourselves from the ground up. It's not based on a vendor tool. It's not sort of an implementation of a vendor tool. And so we're able to move things around and adjust things as needed. BOA also lets you sort of track these cohorts of students longitudinally that you've created. And so you can see here in this demo environment, I've created lots of different cohorts of students based on primarily majors. But what we've also done with BOA is, in addition to just sort of the simple aggregation and representation of the data, we've also introduced an alerting model based on what's happening in real time with students' engagement or disengagement with the Canvas learning management system. And on the home page here, we've sorted students by their number of current alerts. So you can see this is a student here who is enrolled in 5 courses this term, we can see here. And they're really disengaged with the course material. And so we can see across the board, this is a student who hasn't looked at any of their Canvas sites for almost 3 weeks. And as an advisor, we can drill down a bit further just for context and see, in this case, every single student in the course has visited more recently, all but one. So as an advisor, this is a student where with this real-time data insights that the alerts in BOA present, we're able to support interventions by advisors to help bring the student back on track, adjust their course load, something that's going to have a more positive outcome for them than the risk of earning Fs in these courses, affecting their GPA, affecting their progress towards degree. We also hope that these alerts bring insight to advisors that they may not have otherwise had. This is a student with a 3.67 cumulative GPA. This may not be a student that the advisor, based on their historical performance, would expect to be at any risk in the current term. And so with the data-driven real-time insights, we're able to support earlier interventions for advisors and ultimately support students in their progress and time towards degree. So BOA is, of course, bringing together all this data for advisors, and it's also supporting them in their transactional work. I'm going to skip this slide, and I want to talk a little bit more about the alerts, which is we've done some initial analysis looking at the fall data. BOA has been in production for a while, but our need to log the alerts sort of evolved over time, and so we've been doing that since fall 2020. And based on the numbers we've seen there, the spring analysis I've begun, I'll say that all these trends and patterns here continue into spring. I have more quantified data here for fall. BOA is somewhat noisy in terms of the alerts it generates. It generated almost 25,000 alerts. About 40% of undergrads had one or more alert. And as we did a deeper dive, we began to see some real trends or patterns emerge with the alerts in BOA, particularly that, of all the 13,000 students who had one or more alert generated, in fact, a lot of them, it was one alert and that was it. We see the alerts begin to, certain cluster around certain students, and about 3% of undergrads had 5 or more alerts generated. And when we look at these alerts across the board, we really see that all of these alerts seem to align with outcomes that deviate from the norm. On average, about 2% of students get a non-passing grade when we look at fall data. And for all of these alerts we generated, particularly the ones against the Canvas data, that number goes up quite a bit. The passing grades are still quite high. We certainly can't say the presence of one of these alerts means the student's not going to pass a course. But we know that there's a level of risk for the student based on a certain duration of inactivity that we can capture and represent through the BOA alerting model. We found that the timing of the alerts was sort of meaningful as well. The alerts generated earlier in the term seemed less relevant, and that kind of makes sense. We haven't quite established yet what constitutes normal engagement with a course. But as the term goes on, the presence of an alert gets closer to potentially telling us about risk of a student not passing a course. Again, a tremendous number of students still go on to pass the course, but quite a few more than the 2% of normal non-passing grades. We see here these figures that hover around 10%. And I think most meaningfully, what we really saw was that students who generated a lot of alerts had very sort of adverse outcomes in terms of their academic progress. Students with 10 or more alerts, 4 out of 5 of them ended the term on academic probation, subject to dismissal, dismissed, or they withdrew at some point in the term. And when we trim that down a little bit, 6 to 9 alerts, it's still about half of those students that ultimately end the term not in good standing. And again, at Berkeley, it would be about 92.5% of students on average end the term in good or normal standing. So we're seeing from the alerts that just the presence of a single alert isn't so meaningful, but it's the pattern of alerts that really tells us a lot potentially about the students. It looks like there's a threshold of inactivity that leads to students kind of not being able to necessarily complete their courses successfully. The timing, and then the pattern or the quantity of alerts seems to be the most meaningful piece. So based on these insights so far, we're going to adapt this BOA application to show this log that we're capturing internally to advisors. Right now, the alerts are really ephemeral. Once the student takes action, re-engages with the course, the alert goes away. We also need to do a deeper dive in how we generate these alerts. We know that there's multivariate pieces we haven't looked at yet around the student themselves and their characteristics. We know that the trends are going to change as we pivot away from remote instruction into hybrid. We also want to begin kind of bucketing our courses a little bit. We know that there's some courses that are fully online and generate really meaningful learning data, and there's others that are not necessarily using the tools that we're generating data from. So we may not know as much about an insight about student engagement with that material. So that's sort of what we've built, but I want to hand it over to Sandeep to share some details about sort of how we've done it from a technical perspective.
Yeah, thank you, Stephen. Stephen gave a good overview of what the user-facing tool looks like. So I'm going to talk a little more about like what's running under the hood and what is actually enabling us to get the performance and stuff like that. So basically, there were like 3 initiatives that started around the same time back in 2017. As engineers, we were looking into what are some of the efficient ways we can start strategizing our data collection and analytics platforms. And basically, we started moving in the direction of learning record stores and exploring some of the data lake constructs, etc. Around the same time, as a use case, we were also talking to Athletic Study Center, who has a bunch of advisors who were very interested in having some sort of a data-driven solution that could power them. And that eventually grew into becoming BOA, as Stephen showed the roadmap and everything. So why it was important, they were looking for, the advisors were looking for modern toolkit that was not just anecdotal based, but more data driven. We were looking into data as a strategic asset for the campus, not only to power the solution, but also look into doing more robust learning analytics. So centralization of a variety of data from the campus and its partners, right, like was very essential if we were to go in the direction of building advanced data science and analytics capabilities on top. Now BOA supports pretty much the entire undergraduate advising community. That means we have to analyze and synthesize a lot of data for all of the active students and sometimes also the inactive student body. That means it touches a lot of systems on campus. Next slide, Stephen. So I talked about the 3 projects, the LRS, the data lake, and as well as the advising platform that Stephen demoed. This gives a quick interplay between the 3 projects, right? So the Learning Record Store is basically a data store, which is mainly used for collecting event log streams. We are in an IMS conference, so Caliper is one of their standards around the space for data collection. So whenever an activity happens within, let's say, Canvas environments or Kaltura, etc., what happens is the user interaction is packaged into a well-formed structured event, semi-structured JSON event, and it gets pushed into our stack. We collect that information, dethread it, enrich it, and store it in a way for future use. So that's like a very real-time workflow. So basically, we are accepting things as and when it is coming in, and trying to do some analytics on top of it. And then we also have a lot of bulk data sources, right? Like which are probably getting refreshed on a nightly basis, etc. Much of these are like CSV files or database exports, etc. So for that, we needed like a batch processing layer. And that is where another application called Nessie, which is basically a data lake manager, is what we built. And both put together form the actual data lake. And we are synthesizing data from both the batch layer as well as the fast streaming layer to kind of give like a more updated view to the advisors within an application like BOA. So that's like the ecosystem of how things work. Next slide. Yeah, I talked about different data sources that Campus has. Here's a quick overview. Canvas is our learning management system, and PeopleSoft is the engine behind our student information system. So those are like probably two large dimensions of institutional data. Other than that, we have a range of tools, learning tools that integrate with Canvas and is widely used, like Kaltura, Piazza. There is also edX data that we are collecting. There are tools like Gradescope, which are automating how grades are released to students, as well as there are a wide range of shadow advising systems that existed in the past before BOA came into being. And one of the efforts was to synthesize all of those workflows and build something cohesive for the advisors. So in that effort, we had to bring in a lot of advising related data from different systems and house it within our data lake as well. So we can also provide historical data, and advisors wouldn't lose context as they're moving into our platforms. And then we also have admissions data, etc. So all the data sets that you're seeing over here, at least 90% of them, we have already started bringing into the data lake in some shape or form. Next slide, Stu. Okay, the high level goals of the data lake or the design constructs that we were looking for as a solution is, okay, we are looking to get like a bird's eye view on all of the learning data that students are engaging in to get like different dimensions of and aspects of the learning. How do we kind of bring all of that data into some sort of a single source? That was one of the goals. And the second one is reduce our data science lifecycle. So from going from ideations to generation of insights, there are a whole sequence of steps. And using traditional, doing that in traditional siloed systems has its own disadvantages and longer change managements and all of that. So how do we accelerate that process, converting an idea from insights? So that was one of the major criteria. And centralization, I've already talked about it. And one of the key thing is once you bring data from multiple systems, we also need to build like common data catalogs that can span across the different types of data, right? So it's in a central location. Anyone coming in can understand what is there, where it is there, and all of that. Once all of this effort is done, we need like good data processing systems, which are pretty flexible and can run on demand as and when it is necessary. We don't want to lock into a particular vendor because this space is changing so much. And there are new big data technologies coming out every year or so, right? So we wanted to provide an option to have like good good compute options to run our data pipelines, to author our data pipelines, which are highly available and scalable and can stand the test of time, at least for a period of 4 to 5 years. And as a part of all of this centralized solution, we were also looking to establish good data governance models and security guardrails. As you will see in the future slides, we are operating on the AWS cloud, and there was some classic fear, uncertainty, and doubt whenever we brought up like the cloud and we are putting the data in the cloud, etc. So we had to take a series of steps, go through security audits, and ensure that there's good data governance and security guardrails that exist in order to protect all of the information that is being stored. Next slide, Stephen. So in comes the data lake. So the basic construct of the data lake is you provide some sort of a centralized storage and cataloging mechanism where you can bring data from myriad of sources as long as they are in open formats. Traditionally, all of this work was being done in the data warehousing realm. The problem with data warehousing realm is you need to kind of know what the data structure is going to be beforehand, and then you will need to go through a laborious design construct and a phase where you are figuring out like what we're going to store now and also for future, right? And once the design is locked in, then you go about building your pipelines and stuff like that. So there's a lot of precursor work that needs to happen. What the data lake model does is it kind of flips the model where you can bring in the data, then go about building your constructs and definitions and stuff like that, which provides a lot more flexibility. The end result is you will have more flexibility in terms of starting from an idea, starting from a raw data source to actually converting that into a meaningful data source to power your business intelligence applications, run advanced analytics, and also run your data science and machine learning. Next slide, Steve. You might want to wait for the clicks, maybe go back a click. So Nessie is our workflow manager, which basically is a puppet master for the data lake, right? Like it basically manages the assembly line, how we are trying to bring the data in to converting that into something meaningful, metrics, etc. So currently Nessie is deployed as a Python-based application on a service, on an AWS service called as Elastic Beanstalk. But then again, I should say data lake is more a design pattern as opposed to something that you are bound to run only in like one cloud solution or something like that, right? You can leverage only open source frameworks and build your data lake as well. And you have like feature parity, whether you do it in Google or Azure or AWS clouds, any of the public clouds. So Nessie is basically our workflow manager, which deals with a lot of scheduling, what should run when, at what frequency we should bring the data, and all of that. All of that logic is baked in that particular application. Next click. So yeah, here you see a bunch of data sources. This is basically the batch data sources that we are talking about here. Some of the Canvas data that we kind of ingest in this mode is basically the nightly snapshots that Canvas provides. It's a data warehouse export that they offer for all of their clients. And we kind of bring those data sets into a centralized store called as Amazon S3, which is a cheap storage layer. And you can bring data and organize it in whatever shape and format that you want, as long as it is in open source formats like CSV, JSON, Parquet, and Avro, and stuff like that. Then we'll be able to engage a wide range of compute options to actually process this data. And we do the same with other data sets as well around like SIS, advising, edX, etc. Next slide, Stephen. Yeah, once that is done, the next step is to build that common data catalog. There are some automated tools that does that, which we can set during the ingestion process. Sometimes we can go ahead and customize and build our own definitions and stuff like that. If we need to update something, or we are bringing in some sort of a manual source, etc. So there is a service called as Glue, which basically provides this data catalog, which has all the definitions, file formats, and the locations of where all of the data resides. And it uses a standard process called as standard data definition language called as Hive, which makes it easier because that is a schema that basically a lot of compute options, processing layers can understand at this point. Next slide, Stephen. And then you offload this and go ahead and build target pipelines using a range of data processing layers. So one of the things we use is Amazon Redshift, which is great for structured data. And you can also engage layers like Spark, which is very versatile. You can handle anything from structured to unstructured data and hammer it into shape however you need on a per use case basis. So these are some of the compute options that is available, where you can go and author your data mining processes and build your metrics and features, etc. That you can offload it to the next layer, which is going to be the application layer, right? You can kind of offload it to Tableau service, where they can go ahead and build like robust dashboards. If a data scientist is working, then you can provide access via Jupyter notebooks. And we can also provide more meaningful insights to applications like BOA, which is consuming data in the shape of an API to kind of present it to the advisors in more meaningful ways. Next slide, Stephen. So that was the batch processing workflow. I'm going to quickly gloss over the streaming platform and how it works. As I already mentioned, we are collecting Caliper events, which is one of the streaming standards. And currently we are collecting data from Canvas and also a course capture service called as Kaltura. We are in very early stages of getting this data from another service called as Gradescope, which is widely used. It's still in experimental stages, and hopefully we can mature it to a production pipeline. What happens is we provision some sort of a queue where the vendors can go ahead and ship their events, and that becomes a collection engine for us, right? Like all the events come and get dropped in that queue. And then we can spin up like appropriate microservices to actually process this information. And we use a range of tools for this, ranging from Kinesis to Glue, to hammer this into proper shapes, flatten it, enrich some of the information, and also build like meaningful metrics before it's stored back into S3. Once it is in S3, then again, it is accessible via the regular data lake processes to the further layers in terms of delivering those metrics to end user applications. Next one, Stephen. So some of the lessons learned. So the first lesson learned is basically, so these are also like tips, right? when you're building a data lake, you're trying to coordinate across a wide range of teams within your own campus, because you're trying to centralize data that they are collecting as well. And also you're partnering with vendors, etc. So it becomes very imperative to kind of involve those stakeholders early and often, and keep them apprised about like what is going on, what are your plans and stuff like that, because it's gonna um, some of the issues that prop up is around like data access, and if we are not handling the security right or something like that as per the requirements of your security teams, then it becomes a huge challenge later on and can stop the projects in its own tracks. So it is very imperative that you kind of keep everyone apprised, and you embrace best practices around building your security and governance models. One of the things that we did is we have different data protection levels and zones to handle different kinds of data depending on the sensitivity. And also it is always hard in terms of trying to boil the ocean. If you're trying to do everything at once, it's going to become like overwhelming. So one of the key things to do in this particular governance is to ensure you're tackling and prioritizing use cases so that you're keeping focus as much as possible. Next one, Stephen. So there is something called as a data swamp, which can happen. You have heard data lakes. Data swamp is where data lake is mismanaged and it turns into a behemoth later on, which is unmanageable. So how do we kind of avoid that scenario? It's easy to build a data lake in a wide range of cloud offerings that are available. But one of the key challenges is to have an ecosystem around it so that you have good processes, so that you're maintaining your workflows well. And if something's failing, you have contingencies for it, right? And you have to expect that things are going to fail, especially because this is such a dynamic, living, breathing sort of organism, especially if you're consuming data in real time and stuff like that, right? Like processes can fail for a wide range of reasons. It is highly distributed environment. So one of the things to keep in mind is develop contingencies and also self-heal processes. We also need to make sure that there are good good processes around like maintaining eventual consistency use cases versus like some use cases where you need like pinpoint accuracies, right? Like, so it should be, we need to be cognizant of all of those in order to make sure that we are coming up with like good schemes to monitor all of this, all of the stages within the data lake to ensure that there is a smooth process that is running end to end. And embracing the open standards around this is very key. One of the key things that I was advised on is always build something like you're going to exit. Currently, we are in AWS, right? Planning for an exit at some stage will strengthen your ability to design things in a way where things are modular, where things are more conformant to open standards, and you're leveraging open source technologies so that at some point Google gives you a good deal. Then if you want to migrate and stuff like that, there'll be opportunities for that. So that is very essential. And next slide, Stephen. The next one is, in order to do all of this, again, going back to the term about boiling the ocean, right? Like we can't do everything all at once. So doing things in a agile manner and an iterative manner is really essential. Start with like a minimum viable product and basically iterate over them, improve on your processes as and when you go along. If you're starting out with AWS or something, stick to core services like EC2, RDS, S3, etc., until you get like a good understanding of the landscape, and then you can go and expand your portfolio of the services, because there are about like 200 services within AWS offering, and it's same with Google or Azure. And consider sandbox environments to reduce the blast radius, at least in the initial days, and then you can graduate it into your developer environment and QA environments in production, etc. from then on. Next slide, Stephen. Quick time check. So how are we doing? Okay, maybe I should step up. So some of the strategic impacts for this particular project is, as and when we were building a learning data lake, a lot more people on campus got interested, and it got enough momentum to kind of reconceptualize our data as a campus service. And we partnered with our enterprise data warehousing team to basically go ahead and build like an enterprise data lake, which is going to have like a wider audience, more technical resources from across the board, so that we can also get like sustainable funding, establish more enhanced governance and security protocols, etc. So basically all the work we did for BOA, right, like and our own learning analytics portfolio went into becoming a more robust campus initiative, which is currently hosted in the central IT department at this point, and we are slowly migrating some of our workflows as well. So they become responsible for the day-to-day operations, while we become the innovation group trying to push the mantle of data science, etc. Next slide, Stephen. Some of the other initiatives that are going on, right, like not only the learning data initiatives, but embracing the data lake model has helped the campus during the COVID times to bring data from university health services and build dashboards around like COVID testing and vaccinations. And next slide, Stephen. And building a campus building access badge for all of the campus community, which includes students as well, right? So basically, they go through a stage of checks, surveys, and all of that. All of this information is uploaded to Data Lake in real time, and we have a badging system where we classify clearance to different people based on this. Next slide, Stephen. So some of the ongoing data and learning analytics initiatives, we are trying to democratize access to the data lake to a wider audience. So there are a lot of analysts in different groups who are interested in kind of picking up this, picking up their own use cases and running with it. So we wanted to provide options for that. We are also looking into providing research data concierge services. We are already providing to some researchers around LMS enrollments and SIS data. And then one of the major initiatives that is being funded by our provost is understanding trends, online learning trends during the pandemic, right? Like, so we partnered up with a top researcher in the learning analytics space, and some of the questions that we are looking at is, was there any learning loss? How did the faculty and students cope up with the transition? How are the grading and feedback lags kind of affecting the population? How was it before COVID, during COVID, and after COVID, right? So comparing all of that is something we are looking into. We're also looking into building like robust service metric dashboards for our teaching and learning groups, so that instructional designers, etc., are can be a lot more proactive in terms of handling issues as and when they come. Next slide, Stephen. So this is where you take over, I guess. Go ahead.
Yeah, thanks. So I just to sort of wrap up, I want to pivot. So Sandeep and I have shown so far what we've done with BOA as a platform and the sort of technical infrastructure and innovation that's been required to power that, and how it's driven some of other campus initiatives. And so I want to sort of wrap up by raising some of the higher level questions we're increasingly exploring around what it means to be using student data in this way through these learning analytics questions. I mentioned earlier a few kind of service-specific questions we're thinking about with BOA. How do we identify courses that generate good data? How do we leverage some of the data that Sandeep mentioned that we're bringing in from some of the tools like Kaltura that isn't part of our learning model yet? But there's also a piece today where we know that BOA is really focused on what is sometimes called a deficit model, where we're thinking a lot about students through this framework of risk. So we want to keep the students on track. We want to help students pass their courses. We want to create meaningful data about that. And the nature of advising and the nature of a platform like BOA, that's always going to have value. But we also want to really support the efforts that are happening at a campus level to think about advising and student success in a way that's a little bit more holistic. And so what does student success look like beyond sort of a student who is more or less likely to pass their courses in the current term? How do we kind of measure and track student progress? Mary Ellen, I see your question, Chad. If you could expand on it a little bit, I'll circle back to that.
John, okay.
Oh, sure. Yeah. So I have some more slides, but if you just want to fill in some gaps, I can try to speak to your question there. So, Berkeley's always been a university that's really kind of tried to ground our work in the principles of what it means to use data in a way that protects student privacy and is really aligned with ethics. And so here there's a link. You can just Google this term. You don't have to copy that whole long URL. But we worked with our peers in the UC system to really kind of define and articulate what these principles are for working with student data. And we still keep those in mind, but it's also something where I think in a broader level, we're having an increasing organizational and institutional awareness that just generally the technologies we put in front of our users are really never value neutral. They reflect kind of what the organization wants to promote, and we want to align with what the individual advisors want to promote. And our sort of agile development model where we're continuously gathering that feedback means that BOA as it exists today really reflects the goals and priorities of advisors. We also have heard from leadership that in some cases, what we put in BOA almost might help advisors kind of understand what their role is a little bit better, sort of what we choose to emphasize, what we choose to prioritize has the opportunity to shape sort of what advising means and what advising looks like at Berkeley. And so with a more mature production service, we're starting to wrap our head around some of those larger goals or principles. And so I think as we embark on a deeper dive, now that we have a proven application layer, a really solid technical infrastructure, we want to really maintain our alignment with partners. And one of the biggest things we're thinking about right away is how to center questions of equity in this work. We don't need to spend a lot of time using the learning data to kind of circle back to confirming some of the equity gaps that we already know exist on campus. And we have a lot of partners doing research and doing support of those students. So we want to start by sort of how can we support what's unanswered? How can we support and augment the work that's already taking place on campus? We're not really doing truly predictive analytics today. Of course, what we're doing is very descriptive, but at the same time, we're making deliberate decisions at the service level. What data is meaningful? What data is interesting or relevant? And so as we make those decisions, how does that reflect kind of what our priorities and our goals and our values are? And when might we be able to sort of say that we've built something that looks more like a predictive model, that we have enough confidence in, that we can put it in front of advisors and begin to almost, cluster or bucket individual students into perhaps having, certain sort of characteristics based on what the data tells us. These principles are emerging in learning analytics. They also are really well grounded in the academic advising domain. Here, it's just an excerpt from a report put together by the Advising Success Network, really advocating for equity being as the primary lens through which student success efforts are viewed, rather than sort of a secondary or tertiary component of how we make those priorities. And so we really will continue this engagement with advisors, think about how to sort of measure and promote student success that happens outside of the classroom beyond the absence of risk. But again, because advisors still need to know about that stuff, how can we kind of fine tune the BOA alerting models, and how can we get those to a place where they genuinely are models, and that we feel that the data gives us something that's a little bit more predictive about outcomes than what we have in place today. So we're sort of low on time. I see, Sandeep, thanks. You've answered, I think, Mary Ellen's question in the chat. We've got maybe a minute or two for Any final questions as we wrap up the session in chat or by voice, since we've got a small group? Well, yeah, and so I'll just, and Sandeep, thanks for your answer to Mary Ellen's question, and I'll just sort of reinforce that there's a piece here where, yeah, we want to think about learning is tricky. So learning outcomes, measuring individual progress towards that, I think is going to require deeper partnership with faculty and with the academic side of the house. But with the work we've done with BOA, we're really uniquely positioned, I think, today to start thinking about student success, as I mentioned, in terms of Berkeley has what's called the Discovery Initiative, and this really focuses on helping students identify their passions and to turn those into a sense of purpose that'll sustain them throughout their time at Berkeley and beyond. And so how can a tool like BOA generate, capture, and represent data about those sort of more abstract or qualitative principles and goals? It's something that we're increasingly talking about and hoping to pursue in the future.
Some of the modeling approaches and all of that, which I've done in the past, around predictive, right? Like what happens is there's too much variability from course to course, from instructor to instructor, from depending on the practices, right? Like, so it's a bit hard to kind of have like a common model across the board that works for everyone once you kind of fits all sizes, right? So what we are looking more into is looking at cohort-based models and all of that. For that, we are going through a learning exercise via BOA, how things are being used, what is important for advisors and all of that. And hopefully we can translate that into something of a working predictive approach is what we are looking at.
Well, thank you, Stephen and Sandeep. We're at time, and these are just really important services and resources for advisors. I know that from past experience myself, but I just want to thank you for sharing your work and your expertise. There's some additional comments, just really appreciating what you've done and how you've set this up, and just really appreciate it. And thank you to the attendees for spending their time here learning as well. I hope you all have a great rest of your day, and looking forward to seeing more from you all.
Thank you.
Yeah, thanks everyone.
Yeah. If you have any other questions, please do get in touch with us. Thank you.